If we talk quickly about the decoupling capacitors we mentioned earlier on, all sorts of shapes and sizes of decoupling capacitors. I tend to usually use 0.01s and 0.1s, and the 0.1s usually used for around the processor and things. 0.1s I pop between the glue logic and the smaller consumption ICs. Now, I think this is possibly the best type which most people want to use. These are small ceramics, 0.01s, 50 volt devices, they're fine. Obviously if you use something a lot bigger, you're going to find it's going to take up a lot more room. Likewise, if you feel you're good at soldering, then you could always use what I do here. And these tiny little fellas are surface mount capacitors, and you can slip those between the tracks of a Vero board and you hardly see they're there. Very useful. Once again, it's about 50 volt rating on those, so they're well within their capabilities as we'd be using 5 volts. Quick word about the sockets again. We work out where we're going to put everything before we start wiring anything. These are the sockets which we actually need, which is the 42 24s, 3 14s, a 16 and a one for the display. Usually I start with the 40 at the top, but interesting enough you can decide what you're going to put here, whether it's a ROM or RAM or whatever. What I like to do, because the circuit says we have a reset circuit and a clock circuit, it seems like a good idea to put one of the 14s. There's also a couple of resistors associated with the crystal and the crystal, it's a crystal oscillator, plus a couple of there's a resistor and capacitor for the reset. So I think that's a good place to put it. Gives it a little bit room here. One must remember though that you want to have these on the back at the right place to take the wires out and down the board to the different parts of the circuit. Obviously if you have something ridiculously big like a socket which you use for a 68,000 processor, a bit bigger, isn't it, you only have a chance of having one row full with that. Just a very quick pit stop here. Decided this is where we're going to put the first socket, which is the 40 pin one for the 6502. If we turn over and look at the back, you'll see what we've done so far. Now this is how I feel it's a good way to move forward. Always put a red mark at the end. It just reminds one that pin 1 is at this end, whereas normally when you're looking on the top it's at that end. So it just gives us a clue that's number 1. 2 rows of pins, you can see we've already cut with the track cutter some holes in it. Now what I've done here is I've folded over some pins. With the 6502 there were 3 pins that actually aren't connected internally at all. That's pins 5, 36 and 35, and those I have connected up here to just be basically have the pins flattened over and soldered. It holds the socket in place, that's what it's for. Also 2 pins we won't be using in this particular circuit is pins 3 and 7, so therefore 1, 2, 3, 4, 5, 5 is one of the no connected, and 7. So that's what we're doing so far. I'll come back to this when we put a little bit more on. We put a 14 pin socket here for the 7414. That will be both the reset circuit and the clock circuit, so we have some room top and bottom for the crystal and the extra components. At the end here we have a negative connected and negative, and the socket for the positive rail there. So all we're going to do now is simply start taking out the pins one by one. Difficult to see when you're not looking particularly close. And so on, and then you see what we'll have is the row of the track cuts along here. Okay, so this is the next stage. What we've done is we've put in all the IC sockets which we're going to use. There's a lot of spare space, which is fortunate, because what this is going to move on to after I've done this video is I'm going to add quite a few more ICs in there. But this is all we need to show the actual device working. So there we go. We put the crystal in the top. This one had short legs, being used before, so I've put 2 pins in and fixed it in that way. So aside from that, everything seems to be laid out okay. What we do is, one thing I forgot to mention, don't forget to put your mounting holes in at this stage, because when we turn over you find that what we're doing is cutting around them with the track cutter so that the potential screws don't short the short to any of the tracks together here. Right, okay, so you can see now the these little wiring combs here are now in position. Oops, there's one disappearing over there. And what we do is we position them above and below the ICs. You have to work out which way to put them yourself. There's a bigger socket here, there's smaller sockets, and hence we have the little kink there. You work out where it is best. We're going to have the negative rail down here. We can pick up on the negative on that outside track all the way down. The positive all the way down there. Of course, we covered it here, so we have to take it above and below. So what I generally do if I'm adding another one of these combs is take some of the power off here, then put the next one so there's a slight gap between it. Doesn't really matter. These are our bottoms of the pins which I put in for the crystal, and let's go and have a little bit closer look. Yeah, a bit easier to see perhaps. You can see the lineup. What I've done with each one of these ICs is I bent the pins in slightly just to hold the socket in position until I start soldering. I haven't done any soldering with the exception of these bits I already mentioned about the 6502. Other than that, don't forget these are the sort of combs that have pins on the bottom. Some of the other ones don't. They don't always fit in the holes very easily, so just use a spot of glue just to stick them in position. Okay, so what I'll do next is we'll start wiring up the power rails. There's the power rails done now for these bottom three devices. There's the 1414 display, there's the 7400 and the 7493, the divider for the clock, which is just up here, it's not that far away. You can see we've also have some capacitors put in beside. So this is the positive rail. This goes obviously to this pin, then it goes the other way and goes here, and then the negatives up there, and the negatives for these two are down here. So we've run separate wires obviously for each one of those. If we look on the other side, you can see the layout now with the 3 decoupling capacitors in place. What I'll do now is I'll finish doing off the rest of the supply rails for the ICs up on the top. I did initially do a video of myself doing a bit of wiring between a couple of pins, but I found it didn't work because you really couldn't see what I was doing, so I thought it's far better just to do some close-ups and do a little bit of a commentary with it, and then you can see actually what happens. We look, this one here, we are putting, you can see the tip of the wire going down through the hole of the first pin which we want to connect to. Next one is we wrap the pen round the pin, then the next one we run it round a couple of times and then pull it out, working out where we're going to this time. Luckily on this occasion our pin is alongside. You wrap it round this pin a couple of times, then once again work out where it's going next. That's good. We go all the way round to the next one, do the same as before. Now we'd finished on this IC. This unusually has 3 pins connected together. We want to go up the board to the 6502, which is right on the top. So pick the shortest route which you can up to that, and once again you do the pin on the 6502 as you can see here. Then as that's the finish of our run, what we do now is we push down with the pen on the wire on the board with the sharp tip until it cuts off the wire. Let's finish off part 2 of the 6502 video on construction with some construction details on the assumption that somebody might be interested in actually trying to make their own. First of all, let's start off with the simple I/O map and memory. This shows you the memory locations we're going to be using for each part. Next, this is a bit of circuitry which actually shows the reset circuit and the clock circuit. That's fairly easy to follow, there's nothing very complicated there. And lastly we have the big circuit, which is the main circuit showing the CPU, the ROM, the RAM and the decoder and the glue logic. Once again, this is all you need. Don't forget in this particular one there's no full address and data bus lines shown, just to make it much more simple. The thing which you'll need to follow all of the wiring of course is this last bit, which is called the netlist, and following on this I've checked this and this is what I used to actually make the one that you'll see working in the next episode.